Could a rare blood type be the key to ancient human survival? Some believe it's linked to lost civilizations, Ice Age survivors, and even royal secrets. The science is real, but the full story is still unfolding. Stick around and hit subscribe for more mind-blowing discoveries buried in our DNA. Have you ever heard of a language that has no known relatives, spoken by a people whose DNA seems untouched by time? Tucked between the hills of northern Spain and southern France is the Basque Country, one of the most mysterious regions in Europe. Their language, Euskara, is unlike anything else on Earth. But what really sets the Basques apart isn't just how they speak, it's what runs through their veins. A surprisingly large number of Basques, about 35%, have Rh-negative blood. That's more than double the global average. While most people carry the Rh protein in their red blood cells, these individuals don't. It's not just a medical curiosity, it's a genetic anomaly that might hold secrets about humanity's ancient past. Genetic researchers have found that Basque DNA has remained largely unchanged for tens of thousands of years. Some even call it a living genetic time capsule from a pre-agricultural Europe. That's right, these people may be the direct descendants of ancient groups who survived the Ice Age, huddled in isolated mountain regions while glaciers spread across the continent. And it doesn't stop there. In 1991, a mummy was discovered in the Alps, nicknamed Ötzi, the Iceman. Despite being over 5,000 years old, his DNA bore striking similarities to modern Basques. Coincidence? Maybe not. It suggests the Basques didn't just survive. They stayed genetically distinct while other groups mixed and migrated. But here's the twist. The Basques aren't the only ones. Other isolated populations, from the Berbers of North Africa to certain groups in the British Isles, also have high concentrations of Rh-negative blood. They're scattered like ancient breadcrumbs across the globe. And if we follow that trail, it leads us to a much bigger mystery: the pregnancy paradox. Now here's where things get even stranger. Rh-negative blood isn't just rare. It comes with a biological complication that, on the surface, makes no evolutionary sense. Picture this: a woman with Rh-negative blood becomes pregnant with a baby who has Rh-positive blood. If any of the baby's blood mixes with hers during pregnancy or birth, her immune system might identify the baby's Rh protein as foreign and start producing antibodies. The first baby usually makes it through safely, but in future pregnancies, those antibodies can cross the placenta and attack the baby's red blood cells. Today, doctors can prevent this with a shot of a special medication. But imagine this happening thousands of years ago, without hospitals or prenatal care. Many women would have had successful first pregnancies but lost their next child due to this immune response. And in small communities struggling to survive, every child mattered. So here's the big question. If this blood type causes such serious pregnancy complications, why didn't it disappear through natural selection? Why did it persist and even thrive in some populations? The answer might lie in what was happening around 25,000 to 35,000 years ago. That's when the Rh-negative gene deletion is thought to have occurred. A time when small bands of humans were surviving in Ice Age Europe under the constant pressure of extreme environments. Could it be that this trait, for all its risks, came with an advantage powerful enough to keep it around? Let's dig deeper into how isolation during the Ice Age may have protected and even preserved this strange quirk of human biology. Clues in the cold: how isolation saved the gene. Imagine a frozen Europe, blanketed by glaciers, where small groups of humans clung to life in sheltered valleys, coastal caves, and mountains untouched by ice. These were called glacial refugia, rare places where people could survive when most of the continent became unlivable. The Basque region was one such place, so were parts of North Africa and the Caucasus Mountains. And guess what? These are also the areas where Rh-negative blood is most concentrated today. It seems the isolation of these regions wasn't just a physical barrier, it acted like a genetic bubble. Populations in these pockets remained cut off from others for thousands of years. While much of Europe saw waves of migration and interbreeding, these groups held onto their ancient genes, including the one that removed the Rh protein from their blood. So why does this matter? Because it means that Rh-negative blood might not have spread through conquest or travel, but through survival. These people lived through the Ice Age by staying put. Their genes tell a story of hunkering down, riding out the storm, and preserving a genetic identity that dates back tens of thousands of years. But this still doesn't answer the biggest question. Why did nature allow such a risky trait to survive at all? What did it offer that made it worth keeping? The next part of the puzzle might just blow your mind. Disease resistance and the hidden shield. Throughout human history, survival hasn't just depended on shelter, food, or strength. Sometimes it's about what your body can fight off. Here's where things get interesting. Rh-negative blood may offer protection against certain parasites and pathogens. One of them is toxoplasmosis, a parasite that infects nearly a third of the global population. Studies have shown that people with Rh-negative blood are less likely to experience severe symptoms from it. Their blood seems to make it harder for the parasite to take hold. That's not all. Historical data suggests that areas with higher Rh-negative populations may have fared better during some of the worst disease outbreaks in human memory. Take the Black Death, for example. It devastated much of Europe, but records show some Basque regions were mysteriously less affected. Ancient accounts tell of entire villages in Basque Country where barely anyone got sick, even as neighboring towns were wiped out. While the science isn't fully settled, the possibility that Rh-negative blood played a protective role is hard to ignore. Some scientists believe that certain diseases need specific receptors on blood cells to infect people. If Rh-negative individuals lack those receptors, the pathogens simply can't get in. This would make Rh-negative blood a kind of invisible shield. Not perfect, but powerful enough to improve survival odds during ancient pandemics. So while Rh-negative women faced higher pregnancy risks, the trait may have stuck around because it gave their children a better shot at surviving disease. And when you're living in an ice age or facing a deadly outbreak, that edge could mean everything. But now, let's zoom out. If this trait is so beneficial, why isn't it everywhere? The global map of Rh-negative blood doesn't follow the patterns you'd expect. In fact, it paints a picture that breaks the rules of how we think humans migrated. The global map that shouldn't exist. Pull up a map showing the distribution of Rh-negative blood, and you'll notice something odd. It clusters heavily in Western Europe. It pops up in isolated spots like North Africa, the Middle East, and parts of the British Isles. But as you move eastward across Asia, it practically disappears. In places like China and Japan, fewer than 1% of people are Rh-negative. And in many indigenous populations of the Americas and Australia, the frequency is near zero. That pattern doesn't make sense if we believe the classic story of human migration, that all humans moved out of Africa and spread steadily across the globe. You'd expect genetic traits like this to show up more gradually, more evenly. But this one skips around, forming strange pockets. Some researchers believe that the mutation occurred in a small, isolated group in Western Eurasia, and that group didn't mix much with others. Others wonder if early seafarers, long before we thought such travel was possible, spread the trait across coastal regions, now mostly underwater. It gets even weirder when you look at indigenous tribes in North America like the Blackfoot and Blood, who show surprisingly high levels of Rh-negative blood. That's not supposed to happen, based on everything we know about migration. Could this be evidence of ancient contact between Europe and the Americas, long before modern explorers crossed the ocean? It's a controversial idea, but one that genetics refuses to completely dismiss. The mystery deepens when you consider the possibility that this blood trait may have been associated with leadership and power. Royal bloodlines and genetic strategy. You've probably heard the phrase blue blood to describe nobility. But what if that phrase is rooted in something real? Across Europe and beyond, noble families have shown unusually high rates of Rh-negative blood. DNA testing on ancient Egyptian mummies, even some from royal lineages, revealed genetic markers consistent with this rare trait. It sparked theories that ruling families across different cultures might have shared more than just power and wealth. While some might jump to wild conclusions, there's a more grounded explanation. If Rh-negative individuals were more resistant to disease or had unique cognitive traits, they might have been seen as natural leaders. Over generations, strategic marriages meant to protect bloodlines could have preserved this trait. Think about it. In a time when surviving childhood was an achievement and a strong immune system meant everything, wouldn't communities want to keep those strong traits in the family? This wasn't about magic or myth. It was about passing down an edge, one that may have helped certain lineages thrive while others faded. But what if this genetic edge went beyond the physical? The Rh-negative profile. Let's shift gears for a moment. Many people with Rh-negative blood report that they feel different. sometimes in ways they can't quite explain. They notice small changes in the environment, they sense tension in a room before anyone speaks, or they pick up on patterns others miss. Is this imagination? Maybe, but scientific studies have explored subtle neurological differences in how Rh-negative individuals process sensory information. They're not superhuman, but they might be wired just a little differently. Research has also shown a connection between Rh-negative blood and red hair, particularly in places like Scotland and Ireland. It's linked to a variant of the MC1R gene, and its overlap with Rh-negative populations has caught scientists' attention. Could it be that these traits, like increased sensitivity to surroundings, were once evolutionary tools? In ancient times, being able to sense a storm coming or spot danger before it happened could save your life. It's not magic, it's an adaptation, a legacy of survival coded into the bloodstream. Debunking the myths, discovering the truth. Over the years, Rh-negative blood has stirred up quite a bit of controversy. From YouTube theories to late-night forums, some say it's a sign of alien ancestry. Others link it to ancient gods, lost civilizations, or even claim it marks a chosen bloodline. But here's the truth. It doesn't take myths to make this story extraordinary. Let's clear the air. Rh-negative blood is a natural result of a genetic mutation that most likely occurred between 25,000 and 35,000 years ago. It removed a specific protein from red blood cells. That's it. No science fiction involved. But what makes this simple mutation so remarkable is what it tells us about how early humans survived. It adapted and passed on traits that could make the difference between life and loss. Still, you might wonder, if it's just a mutation, why do so many myths surround it? Well, humans love stories. And when something seems rare or unexplained, we tend to fill in the blanks with imagination. That's especially true when traits seem to link across time and cultures, like Rh-negative blood appearing in royal families, isolated tribes, and ancient populations. It's easy to see how a rare blood type, combined with mysterious genetics and historical survival, can turn into a story of divine origin. When people in power also happen to carry this trait, the mystery deepened. But science offers a more grounded, though equally fascinating explanation. Royal families likely passed down Rh-negative blood, not because of prophecy or supernatural power, but because of centuries of selective marriages. Families tried to preserve what they believed were strong, pure bloodlines, perhaps noticing patterns of health or resistance without fully understanding the genetics behind them. In isolated populations, Rh-negative blood remained simply because those communities didn't mix much with outsiders. Their isolation worked like a genetic time capsule, keeping certain traits alive while others disappeared through interbreeding in more connected parts of the world. That's the real marvel. This blood type is a remnant of survival, a living fossil in your veins. Science has now gone a step further. Using modern genetic testing, we can actually trace the journey of Rh-negative blood across time. It shows us how ancient groups might have moved, where they settled, and even how they responded to dramatic shifts in the climate and disease. It also teaches us something important. Evolution doesn't always favor traits that make life easier. Sometimes it preserves traits that carry risk, because the reward is even greater. Despite pregnancy complications, Rh-negative blood stuck around, likely because it provided protection from life-threatening illnesses at critical points in history. And even today, this blood type continues to matter. Blood banks are often short on Rh-negative blood, especially O-negative, the universal donor type. If you carry it, you have something that can help save lives in emergency situations when time is critical and there's no room for error. Beyond emergencies, researchers are still discovering new ways blood types influence our health. Some studies suggest Rh-negative individuals may be less prone to certain autoimmune conditions. Others are exploring possible links between Rh type and how we respond to viruses, medications, or even inflammation. So when we peel back the myths, what we're left with is still amazing. A rare genetic trait, passed on through generations, that tells us a story of hardship, survival, isolation, and resilience. It's a chapter of human history that was almost lost, but has remained hidden in plain sight, carried in the blood of millions around the world. We don't need aliens to make the story exciting. The real science, the story of who we are, how we lived, and what our ancestors overcame, is far more compelling. And the more we study it, the more we uncover not just about Rh-negative blood, but about ourselves. That's what makes this mystery so powerful. Not because it came from the stars, but because it came from us. From real people who faced real challenges, adapted in incredible ways, and passed on their strengths through something as simple and powerful as blood. So, what story does your blood tell? We've traced a journey that spans continents and thousands of years, from icy mountain caves and forgotten coastlines to modern science labs and hospital rooms. Rh-negative blood isn't just a rare type. It's a living link to the resilience of our ancestors. And whether you have it or not, your own DNA carries echoes of ancient choices, hardships, and victories. Now it's your turn. Tell us in the comments, do you know your blood type? Have you or someone you know experienced any of these Rh-negative quirks? And don't forget to subscribe for more fascinating deep dives into the hidden genetics that connect us all.